What's up everyone? In this video I'm going to be covering all of the 12 volt accessory wiring for the KLS 250 SF conversion. I'm going to go over all of the wiring for the basic accessories like the headlight, brake light, turn signals, and display, as well as sections covering the wiring harness for the Fardriver controller and even a mini crimping tutorial. It's a pretty long video, so please feel free to use the chapter links in the description to jump around to the different sections. If you're new to this channel, this video is part of a series where I convert a Kawasaki KLS 250 Enduro dirt bike to electric. So please check out the other videos in this series, which are also linked in the description. And if you like this kind of content, please let me know in the comments and hit that thumbs up button. Alright, now on to the video. Alright, so now we're doing the wiring for the headlight. I've got the headlamp on right there, and I've got a switch here. So this switch has high beam and low beam. Basically, low beam will be always on, and then when I flip the switch, I'll have a high beam. And the way that works on the connector, so this is the connector for the headlight. You've got a ground, which is the black wire, and then one of these is the low beam, and when you connect that to 12 volts, you get a low beam, and when you connect the other one to 12 volts, you get a high beam. So basically you have ground, and then you switch between these two to get low beam and high beam. And then with this switch on the connector here, I've mapped all of these out. I have a mapping of them and what they do. It didn't come with instructions. I just had to figure it out with a multimeter. So the headlight switch is broken up over these bottom three wires: the white, the blue with the white line, and the blue. So the middle wire, the blue and the white, is the common wire. I guess that's a bit intuitive. And when you flip the switch, I think nominally it's connected to white when the switch is down for the low beam. And then when you switch to the high beam, it connects the blue and white wire to this blue one. So this one's common, and then it just switches between the two. So what I'll need to do is connect 12 volts to this middle blue and white wire. And then I'll connect the low beam headlight to this white wire, and then high beam headlight wire to here. And then when I switch, I'll go between low beam and high beam. I already have a dongle cable for the headlight. This is ground. This will go to my ground junction. And one of these is the low beam, one of these is high beam. I think yellow is high beam, probably, the way I wired this. So all I need to do is connect 12 volts from my connector to this middle line, and then these two I need to connect to the white and blue wires. All right, so here I'm just quickly going to show how I crimp these connectors in case that's interesting to anyone. I'm using these weatherproof connectors that I got on Amazon. These are pretty cheap, and I think they're like knockoff versions of these Delphi MetroPack connectors. So these are more expensive, but honestly, I can't really see the major difference. I mean, the one obvious difference is that this has the 6-pin connector as 2 rows, and this one has it as a single flat 6-pin connector. I'm using this flat one because it makes better space inside the bike, because you can just basically arrange them flat as opposed to having something that's a little more bulky. I'm using 14 gauge wire for all of this. That should be more than enough. So I'm just crimping it here. And these connectors, they have this is the male pin that you're using. All right, so that goes just like that. But the weatherproof part comes from these rubber little grommets or something, and they go on the wires like that. So the end should be aligned with the end of the installation, because the way these work is that the wings on these little crimp connectors are going to go around that little grommet, and then the smaller wings are going to be the ones holding the wire. So in case you've never crimped wires before, that's the idea. So one thing I do crimp them with actual crimpers, but before I do that, just so they stay in place, I just kind of like lightly bend these around so that it's not as difficult to keep this in place when I do the final crimp. Okay, and that's going to be enough to hold it in place for me to use the actual crimper. So this is a crimper made specifically for this type of connector. It's actually a crimper for the Delphi connectors, but again, these are exactly the same as far as I can tell. And the way it works is that you put this in with the wings facing into the deep recess, right? So the wings go down into the recess, so that way the back of the connector is sort of being pushed down by this upper portion. So the rounder parts are for the parts that goes on the insulation that's kind of holding the terminal in place. And then the more, like the smaller parts with the sort of W shape down here like this, that's for the actual terminal that's going to hold the bare copper. So right there. And then you just crimp it down and it makes a perfect loop around it. So now for the copper portion, that needs to get crimped using this die right here. And again, we're placing it face down. So with the wings facing down, so just like that. And then it makes this perfect hold. Oh, and then there's an illustration here about how to insert these. So this is going to be, you insert them with the wings up this way. So in case you're using this, this is the little notch where the other female connector sort of hooks onto. So you want to place the notch facing down, and then the wings of this, these little wings over here, are facing up. And I think I'm going to put the headlight on this one. And then it snaps right in there. Okay, so now we'll put this piece back in place. So next I have to make the other side of this connector. And that's one of these. This is the female side. Then if I match these up, the blue and white wire where I'm trying to send those, the 12 volts, is going to be on this middle pin. So these connectors use this type of terminal, and I believe this is the correct crimper for these types of terminals. And this one is a ratcheting crimper, and it does the wings that hold it onto the cable and the terminal at the same time. So now let's just strip it. All right, I'll do the same thing here by just bending these in place so that it holds better. And then I believe this goes in the largest die over here. It has this little notch up here that aligns down with the notch, the little notches here. Snaps in like that. Now I have that common 12 volt line connected to the common line here, and that goes to 12 volts. So now I figured out that red is low beam and then orange is high beam. So then that means the red needs to connect to white, and then orange needs to connect to blue over here. So I'm just going to cut these to length, and I'll just need to, basically loop them over to connect them. All right, so here's that connector done. So that connects right here. And then this piece connects, right, like that. All of that should be connected, and when I turn the switch, there we go. Nice. So that's the low beam and that's the high beam. All right, next we have the kill switch, and I'm going to be using this for the contactor. This basically opens and closes the contactor. I had another switch here previously that I was just using for testing, but this is the actual switch box that I want to use, so I have to swap it out. So as far as the kill switch goes, that is going to be on this connector here. It's the orange and gray wire. So those are disconnected when the kill switch is off. And then when you close the kill switch, the orange and the gray wire will be connected. So I need to wire it up that way to the contactor. So I already had that wired up. These two, this one and where is it? These two wires are the 12-volt line for the contactor. So I just need to run these through that switch, and then I'll be able to turn the contactor on and off. So there's that connection in place, and I should now be able to turn the bike on. There's the light, and this should close the contactor. And there, you can hear it closed. Next, we'll wire up this low speed, medium speed, and high speed switch. So the high speed, low speed function on this controller is on this blue connector here. And the middle wire, the black one is ground. Then when you connect ground to the blue wire, that's low speed. And when you connect it to the yellow wire, that would be high speed. And then when nothing is connected, that's medium speed. So this switch here, you have the position all the way to the right, the middle position, and the position all the way to the left. And the way this works on the connector is that when it's on the all the way to the right position, there are no connections at all on the connectors. So that will have to be my medium speed. Then this middle position corresponds to, it's basically on this middle row of wires. So you have that brown and white wire, then you have a brown wire in the middle and a blue wire on this side. So the middle position corresponds to the middle brown wire connected to this brown and white wire on the side. So that can be my low speed. And then when I flip the switch all the way to the left, that middle brown wire is going to be connected to this blue wire, which will be my high speed. So basically I just need to take that middle row and run it to this connector and my speed switching will work. All right, well, here I've made the cable for the 3-speed switch, and I've used the color scheme that matches the connector here. Here I'll just connect it on this side, and then I'll run this up. Well, my video cut out, but here's the connector in place. I actually put this heat shrink to cover this, but actually maybe I'll take these out and run it under the heat shrink. I'll probably do that later. But that should be connected correctly. And now the high speed, low speed switch should work. So let's test that out. So let's turn the bike on. And then let's activate the contactor. And this setting on the right should be the regular medium setting with nothing connected to the controller. All right, then this setting should be the low speed. So I've got it on full throttle right now, and it's indeed pretty low. And this should be high speed. Nice. So that works. Low speed, medium speed, and high speed. Now, as I guess I would have liked all the way to the right to be low, and then medium to be medium, and then all the way to the right to be high. but unfortunately that's not how this is configured. But there we go. So we have the kill switch working. We got the lights working with high beam and low beam. We've got the high speed, low speed switch working. All that's left is the horn and then the turn signals. And then I also have to set up the tail light. And the tail light's going to be, running on the same line as the headlight. All right, the next thing I want to do is swap out some of these connectors because they're a bit bulky and there's an opportunity to attach some more low profile connectors to them. For instance, this throttle connector is one of these, but the one I have on my throttle is this DuPont connector, which is more common. So I'm going to swap this out for the female side of one of these. And some of these that I might not use, I might remove the connector entirely and just wrap the wires with some heat shrink so that they don't take up, they take up less bulk also. But before I do that, I just want to go through each one of these wires and explain what they do. So this wire, along with this wire, are for the speed sensor for the display. I think one is analog and one is digital or something like that. I'm not really sure, but they both contain speed data from the controller. Then this wire, of course, is the throttle. Then these two red wires are for an alarm system. And I'm not quite sure how to use these just yet. I assume it requires a specific alarm system that will take the signals that each of these, signals and power that each of these connectors provide. So, but those are for the alarm. Then this gray wire is for your high brake. So if you provide 12 volts to this gray wire, the brake will activate. So I'm going to use this for my brakes. But I'm also going to replace this connector because it's one of these weird kind of connectors that I don't have the other side to. And there's kind of no reason for it to be this bulky just for one wire. I'm actually going to put something like this on. That's a lot more low profile. Then the same goes for this connector. It's another one of these. I'm going to replace it, but this is for the power on the controller. So if you provide high voltage to this wire, it will turn the controller on. Then this one is the 3-position speed switch. The middle is ground, and if you connect ground to either one of these wires, you'll get low speed if you connect it to blue and high speed if you connect it to yellow. Then this next wire, let's go with this one, the black and yellow wire, this is your low brake. So if you connect, this is ground, and if you short these two, the brake will activate. So if you connect ground to the yellow wire, the controller will activate the brake, which basically means turn off the controller. So the idea is you don't want, when you're using your brake, you don't want the brake to be fighting whatever throttle you have. So, fighting the controller. So this way, when you close your mechanical brakes, it will cut out the controller temporarily to allow you to brake. Then this wire this is reverse. Yeah, this is black and then a brown and white wire. So if you short these two, and the black is ground, and if you short it to this brown and white wire, you'll put the bike in reverse. So the motor will turn backwards. I'm not going to use this one actually because, it's barely a useful feature for a motorcycle. I've never needed a reverse for any reason. So I'm going to remove this connector and then wrap these wires just to save space. Then this wire is your cruise control and your parking brake, I guess. So I believe the red and blue is cruise control. So if you connect this one to ground, then cruise control will activate. The controller will maintain the speed at which it's turning the motor without having to input throttle. And I'm hoping when you apply the brake, that will deactivate, same as regular cruise control on the car. And then the brown wire is your parking brake. So if you connect this to ground, the motor will lock up. So it's going to use power from the battery to actually lock the motor. So I'm not sure how much of a parking brake this is. I mean, it is. It's kind of like an emergency brake, right? I guess if you're parking on a hill and you don't want the bike to, let's say, roll backwards, you would use this. But of course, it takes power to do that. So it's not something that you want to leave on overnight because you'll drain your battery. And this, of course, is the hall sensor wire. And then this wire is for serial connection to a computer or this Bluetooth dongle. So this connects here and you can use the Bluetooth app. All right, well, here I have all the connectors changed, and these wires that I'm not going to be using, I just wrapped them in some heat shrink. Then I've got my DuPont connector on the throttle line. Then these two have connectors like this. This one, unfortunately, the heat shrink kind of receded, so I'll have to wrap it, but it's probably a good idea to wrap it in some electrical tape anyway. So I'll do both of those. And that's pretty much it. Everything else is the same. And here is the controller harness back in the bike with all of the new connectors. It's definitely lower profile. I've got everything hooked up and tested and it all works. All right, so here I am working on the taillight assembly, and I realized that I wanted to attach the turn signals, and they have these little brackets, but they didn't really fit anywhere on this taillight piece. So I just drilled another hole and added a countersink to place these right here. And then the turn signals will screw into this portion and kind of come out of the side of this tail light assembly like that. Here's my tail light and turn signal section. I've got these brackets. I had to drill bigger holes for the turn signals. They actually didn't fit through those holes that they came with. I don't know why, but I got these brackets attached to the back of this tail section bracket, and then the turn signals are attached as well. And there you go. So now basically I have the ground here. I'll have to connect it with these grounds as well. I don't know if I'll maybe redo this wiring and splice them all together so I just have one ground for everything and I don't have to deal with it. But of course the positive lines for the turn signals are to activate the turn signals, so those will have to be separate. And of course that's the tail section. So I'll come up with some scheme for connectors back here. All right, and here's my final tail light turn signal assembly. I'm just gonna throw this on the bike and then I'll wire all these connections to the controls on the bike. The next thing I'm gonna do is hook up the power for the tail light. So that's gonna turn on at the same time as the headlight. That's just gonna be on that switch. And then I actually need to do the turn signals and the brake light. All right, so now I've got the front turn signals on and I have those partially connected. I just connected them to ground, and those are their 12-volt positive lines just hanging out there. I spliced their grounds together and into one line, and I'm just running this one line to my ground junction. I've also connected the rear tail light, so I just have another ground from the junction running all the way up here to this connector. And then I also added another positive 12-volt line, the second one, that's on this last fuse line, and that's also running to this connector here. So this will be the running light for the tail light. This common ground is connected for the tail light and both of the turn signals. So I have them spliced together in this connector as well. So that's the ground for everything back there. But then this one 12-volt line will be the running light for the tail light. And then this green line on this side is going to be the brake light. And then the two wires on the sides are the turn signals. But for now, I can connect this. And then turn the bike on. And we've got the running light working. Okay, next we're gonna do the turn signals, and it's just this 3-way switch. And the way that works on the connector is the positions of the switch correspond to this middle row of wires. So the orange, the gray one in the middle, and this light blue one on the side. So the gray one in the middle is the common line. And then when the switch is in the middle position, nothing is connected. Then in the right position, that middle gray wire connects to the light blue wire. And then the other position, the gray wire connects to the orange wire. So basically we'll have to run 12 volts to this gray wire. So that's going to be the common. And then each of the signal positive lines, the turn signals, will need to be run to the respective wire on the sides. So here's the turn signal common wire in place. It's the one in this directly in the middle. And that's running to 12 volts. Back here, basically I have it splitting off the tail light line. So I didn't add a new line to the connector just for the turn signals. The tail light and the turn signals will be on the same power lead, which is very low current. So I'm just using this type of connector to split off of that line and run that to this common pin. Here is the connection for the left turn signals. I just have both positive lines on the turn signals spliced together into this one connector. And that's gonna go, that needs to attach to this orange wire. So that's gonna go right there. Here we have both turn signals connected. I have them on these two leads that are spliced together at the terminal. And then I have a little bit of heat shrink to keep the wires secure. And again, that middle line is the 12 volt line, and then the 3-way switch switches between connecting the middle line to the left or to the right or to the left. So now when I turn the power on, I can turn on the turn signal, and that's the left. And this one is the right. Next, it's time to do the brakes. So the way it works is that I want the brakes here, and then I don't have the foot brake down there. I'm actually just painting it black at the moment. But the foot brake as well, when I press on either one of those things, it should, first of all, activate the brake light. So that should turn on. And also it should send a signal to the controller to activate the brake feature on the controller. So the way that works on a switch is that, you know, in all motorcycles, basically, there's a switch that attaches to the brake lever itself, this switch right here. And when you activate the brake, these two pins short. So on the handlebar controls, you have these two wires and they attach over here. You can attach them either way. So there you have the two leads connected to the brake switch. And as you can see, it's a green wire and a black wire. And if you follow that through to the connector, there's a green and black wire on the connector. So when you activate the brake, these two wires will short. And all I need to do is pass 12 volts on one of these wires and connect the other one to the brake light lead. And then my brake wire will work. But I also need to pass that same 12 volt connection to the gray lead on the controller. So I'll need to split it off somewhere. All right, so now I've got the front brake done, and that's now on this connector here. I have it set up where the rear brake light is activated when I use the brake lever. And then I also have this white lead. This goes down to the gray wire on the controller for the high brake input. So the motor will cut out when I use the brake lever. So let's give that a try. So I've got my lights on. I've got my rear running light working. And then when I pull the brake lever, the brake light works. But also, here if I hit the contactor and then run the motor, and then when I hit the brake, right now, so that's the brake. And then when I let go, it goes back to the speed that it originally was. So now all I have to do is the same thing for the rear brake. I don't have it on right now, so I would have to set it up as a either or situation. So the same function, but when I use the brake pedal as well. All right, now I have the foot brake integrated into the circuit for the brake signal. So it's gotten a little messy here, but I used some of these splitters to tap into the tail light brake line and also the 12-volt source. And that's just simply going through the switch that's attached to this original rear brake switch. So now when I press the foot brake, you can see the tail light turning on and off just as if I'm pressing the handbrake. And then that line where I'm tapping into the rear brake is also connected to the signal line, to the 12-volt high brake input on the controller. So when I use the foot brake, the controller will also activate the brake function. And finally, we have the horn, the accessory that I've literally never used in earnest on a motorcycle. So the horn, I really didn't come up with a great place to mount it. I should have thought about it a little bit. Really, somewhere in here would have been a great place for it, but I kind of dropped the ball on that one and didn't think ahead of time. But now I'd have to, take a lot of this apart just to come up with another mount. So I found a good place for it here. This horn has a M6 bolt for mounting, and there was a lot of stuff mounted back here using M6 bolts. So I managed to just kind of screw it on here. It's on there nice and sturdy. And I already have the negative line wired up to the central ground junction. So all I need to do is run a positive line here. This is another 12-volt line that I have coming from my connector here. So this is going to go to this green line over here, and then this switch is wired between this green line and this light green line. So I'll attach the 12-volt power here, and then the other side will be attached to this light green line. All right, and now I have the horn connected. I've got the positive line that's connected through this switch, and of course it's here. So if we turn the switch on and hit the horn, like I said, I'll probably never use it. The one thing I changed on this control is there used to be like an engine start switch here that's similar to the horn where you press it and it bounces back. So I took that out and replaced it with this type of switch that stays in place. And I'm going to use this for cruise control. So there's a cruise control feature on the controller, and when I flip this, cruise control should activate. I don't have it currently wired together, but the cruise control would activate when I flip the switch and hopefully deactivate when I use the brake or turn the switch off. And finally, we have the display. So I have the display mounted on the bracket where the original display was mounted. I had to make a little bit of some changes to the mounting holes. I just filled that in with weld material, then drilled some holes to actually mount the display. But the way this display works is you have a connector here, and the display is powered via the red and black wires, and then it takes battery voltage. So not the 12-volt source, but the high voltage source from the battery. Black being ground, and then red being your positive battery terminal, basically 100 volts in my case. Then the other lines, I'll put up the schematic, but basically they take I think the black and white is the speed data from the controller. So it's gonna run the speed wire. Then the others are turn signal and headlight sources. I'm pretty sure when I provide 12 volts to those wires, there'll be some icons on the display that turn on, indicating that I'm using my turn signals in my headlights. So not like super useful, but I guess also pretty cool. So I am going to connect those. But right now I just have the ground and the high voltage source on these leads over here. And then when I plug this in, the display should turn on when I turn on the bike. So moment of truth. Well, there we go. So now I've got the headlight connected to the display, and I have it connected on the high beam. So when I flip the high beam, I get a little icon on display telling me that my high beam is on. Okay, next we have the speed signal, and that attaches to this light blue connector here on the controller. So there's also purple speed line, which is labeled as the analog speed line. I'm not really sure what you would use this for. Maybe if you have a different display, it takes an analog signal, you would use this line. But this is the digital speed signal. So I have this running on this blue wire up to this connector over here. And that speed line is on the black and white wire that's right here in the middle. And then when we turn the bike on and engage the contactor, you can see the speed show up in kilometers per hour. Now, obviously that needs to be configured somehow, because that of course depends on your gearing. So I'll address that later. I'm sure you can do it in the app somehow. Now I have the turn signals wired into the display as well. I just have them split off the turn signal lines going into that connector for left and right. And now when I turn the display on and hit my left turn signal, get a little flasher, right turn signal, get a flasher, and then that's my high beam. And there's my speed. So the display is completely set up. And now the wiring is done. I've got everything connected. I've got the display working. I tidied up some of the wires underneath the headlights, so they're kind of in there. I'm gonna have to later, once I give this a test ride, I don't want to make the wiring harness now and wrap everything up just in case I have some issues where I need to go in and change something. But once I go on the test ride and everything seems to be working okay, I'm going to wrap all of the wires into a harness. But for now, I've got everything working. So if I turn on the bike, I've got my display. So then if I hit my high beam, it'll show me that my high beam is on. Then my turn signals also work. I've got my turn signal indicator on the display, and then both front and back left turn signals work. There's the running light. Then here are my right turn signals, as well as the indicator. Then I have my horn. Also my contactor. So that engages the contactor. Then I can run the motor. And if I hit the brake, the motor cuts out. I've got my brake light here. And if I hit the foot brake, that's the foot brake. It's the same thing. So all of the wiring is ready to go. This bike is ready to ride. All I need to do is put on a chain. Thanks so much for watching. Next video, we're going to get a chain on this thing and then take it for a test ride. So look out for that, and please like and subscribe.